Good day out there, YouTube. This is once again Professor Friday from Macomb Community College. I've had a request from one of my Calc 2 students. We've been finding derivatives of inverse functions using original functions. So the task at hand for today is given f of x equals cosine of 7x on the interval x goes from 0 to pi over 7. We need the domain restriction in there to guarantee that the function is 1 to 1 and therefore has an inverse. We've been asked to find f inverse prime of 1. Now, the relationship that we have is that for derivatives of inverse functions is if the point AB is on f of x, then the derivative evaluated at the inverse function of b is equal to 1 over the derivative of f evaluated at a. So this is a pretty important relationship. Now, based on what we've got up here, that means that the value given to us is the y-coordinate of the original function. So we have to pose the question, for what value of x is f of x equal to 1? Now, coupled with that is our domain restriction up here. So it's really what value of x on this interval will f of x take on a value of 1. So with that in mind, we'll go ahead and set f of x, which is our cosine of 7x, equal to 1. Now, on this interval, from 0 to pi over 7, the only time that the cosine takes on a value of 1, if we think back to our unit circle, is when the angle is equal to 0. The alternative that we could do is take an inverse cosine of both sides. Inverse cosine of 1. But the inverse cosine of 1 is equal to 0 radians. Therefore, the x value associated with this is going to be x is equal to 0. So put it all together, and we have the point on y equals f of x is the point 0, 1. Now, within the context of the problem, what that means for us is that f inverse prime of 1 is going to be equal to 1 over f prime of 0. That's again using this formula that we have back up here that we derived during class for the relationship between derivatives of inverse functions. Now, what that means for us is we have f of x is equal to cosine 7x. That means we need to take the derivative of this, and then we'll set it, we'll plug in x equals 0. So f prime of x is equal to, the derivative of the cosine function is the negative sine function. However, since the argument is not simply x, it means we're going to have to apply the chain rule and multiply by the derivative of whatever our angle was. Now what that gives us is that we have negative sine of 7x times derivative of 7x is 7. However, if we plug in x equals 0, we are going to get f prime of 0 is equal to negative sine of 7 times 0 times 7. I got bad news bears for that one. Sine of 0 is equal to 0. Which means that if we come back to the thing that we were trying to find right back up here, we just got that f prime of 0 was equal to 0. What's the issue? Well, that sucker's in the denominator. Unfortunately, we are not allowed to divide by 0, so instead of 0 there, I'm going to put a little sad face. That's right. It's a sad face, because we're not allowed to divide by 0. Put it all together, and what we get is that this derivative does not exist. We said during class that this relationship holds only when the x value is within our domain, and when these values, the value of the derivative of the inverse and the value of the derivative of the original function are well-behaved numbers. Throw in a 0 in the denominator, that is not a well-behaved function. So that concludes it for today. Thank you for submitting. I hope this was helpful.